Hello students, today's topic is Cauchy's root test or Cauchy's nth root test, which is used to test the convergence of an infinite series. Statement: if sigma un is a series of positive terms, such that limit n tends to infinity, un power 1 by n is equal to L. Limit n tends to infinity, un power 1 by n. Here un power 1 by n means nth root of un. Okay. Then sigma un is convergent if L less than 1, sigma un is divergent if L greater than 1, and if L equal to 1, the test fails to decide the nature. The test fails to decide the nature of the series. Okay, this is Cauchy's nth root test. But when will we use this test? Generally, when the nth term has exponents of n, we use Cauchy's nth root test. Now we will do some problems on Cauchy's nth root test. First problem: test the convergence of the series sigma 1 plus 1 by n whole power minus n square. Solution: given series is sigma 1 plus 1 by n whole power minus n square. Here un, nth term un is equal to 1 plus 1 by n whole power minus n square. So now find the limit. Limit n tends to infinity, un power 1 by n, that is nth root of un, is equal to limit n tends to infinity, un is 1 plus 1 by n whole power minus n square whole power 1 by n. Okay, this is equal to limit n tends to infinity, 1 plus 1 by n whole power minus n square into 1 by n, that is minus n, is equal to limit n tends to infinity. This can be written as 1 by 1 plus 1 by n whole power n. Okay, we know that limit n tends to infinity, 1 plus 1 by n whole power n is e. That's why this is equal to 1 by e. Since limit n tends to infinity, 1 plus 1 by n whole power n is equal to e. Okay, and 1 by e less than 1. Since e lies between 2 and 3, that's why 1 by e less than. Limit n tends to infinity, un power 1 by n less than 1. Therefore, by Cauchy's nth root test, sigma un is convergent. That means given series is convergent. Test the convergence of the series. 2 by 1 square x plus 3 square by 2 cube x square plus and so on plus n plus 1 whole power n by n power n plus 1 into x power n plus and so on, where x greater than 0. We have to test the convergence of this series. Here nth term un is equal to n plus 1 whole power n by n power n plus 1 into x power n. Now find the limit. Limit n tends to infinity, un power 1 by n, that is limit n tends to infinity, n plus 1 whole power n by n power n plus 1 into x power n whole power 1 by n. Okay, this is equal to limit n tends to infinity n plus 1 whole power 1 by n, that is n plus 1 by, this is n power n plus 1 can be written as n power n into n power n plus 1 is equal to n power n into n. N power n whole power 1 by n is n into n power n 1 by n. N power 1 by n into x power n whole power 1 by n is x. Okay, this is equal to, now take n common here and cancel n. This becomes limit n tends to infinity 1 plus 1 by n power 1 by n into x. This limit is equal to 1 plus 0 by 1 into x. Since limit n tends to infinity, n power 1 by n is 1. Since limit n tends to infinity, n power 1 by n is equal to 1. That's why this is equal to x. Limit n tends to infinity, un power 1 by n equal to x. Therefore, by Cauchy's nth root test, sigma un, that means given series, is convergent if x less than 1 and divergent if x greater than 1. And if x equal to 1, this test fails. Since this limit equal to 1, the Cauchy's nth root test fails. Okay, and when x equal to 1, we use another test to decide the rest of the series. When x equal to 1, un is equal to n plus 1 whole power n by n power n plus 1. Okay, now this can be written as, by taking n common here, n power n, cancel n power n, this becomes 1 plus 1 by n whole power n by n. Okay, now take Vn equal to 1 by n. Now find the limit n tends to infinity, un by Vn. This is un and this is Vn. Un by Vn. This n cancel. This becomes limit n tends to infinity 1 plus 1 by n whole power n. This is equal to e, which is not equal to 0. Limit un by Vn not equal to 0. Therefore, by limit comparison test, both sigma un and sigma Vn converge or diverge together. Okay, both series converge or diverge together, but sigma Vn is equal to sigma 1 by n is divergent. Therefore, sigma un is also divergent. Okay, hence the given series is convergent if x less than 1 and divergent if x greater than or equal to 1. Okay, next problem. Test the convergence of the series sigma 1 by log n whole power n. Sigma 1 by log n whole power n. Okay, solution. Here nth term un equal to 1 by log n whole power n. Now find the limit. Limit n tends to infinity, un power 1 by n. That is, limit n tends to infinity, un is 1 by log n whole power n. This whole power 1 by n. Okay, this becomes limit n tends to infinity. Now this is log n whole power 1 by n. Here this n cancel, 1 by log n. And you know that as n tends to infinity, log n tends to infinity, and log n tends to infinity. That's why 1 by infinity is 0. Okay. Limit n tends to infinity, un power 1 by n is 0, which is less than 1. Therefore, by Cauchy's nth root test, sigma un is convergent. That means given series is convergent. Next one. Test the convergence of the series sigma n power n square by n plus 1 whole power n square. Here nth term un is equal to n power n square by n plus 1 whole power n square. Therefore, un power 1 by n is equal to n power n square by n plus 1 whole power n square whole power 1 by n. That means n power n square whole power 1 by n, that is n power n by n plus 1 whole power n square whole power 1 by n, that is n plus 1 whole power n. Okay. Now limit n tends to infinity, un power 1 by n, that is limit n tends to infinity, n power n by n plus 1 whole power n. Now take n common here, this becomes limit n tends to infinity, n power n cancel, 1 by 1 plus 1 by n whole power n. Okay, this is equal to 1 by e, and you know that e lies between 2 and 3, that's why 1 by e less than 1. Limit n tends to infinity, un power 1 by n less than 1. Therefore, by Cauchy's nth root test, sigma un is convergent. Okay, that means given series is convergent. Okay students, thank you so much for watching. See you in the next video.